Good morning, students. Today we are going to start a new topic in the subject of chemistry O levels, that is acid, bases, and salts. And the first topic out of this topic we are going to read is acid. So concentrate yourself. A lot of the concepts, a lot of the equations and the formulas will be involved. So you have to concentrate. So we are going to start. Concentrate yourself now. Acids. First, we are going to read the definition of the acids. An acid is a compound which, when dissolved in water, so this is the condition, when dissolved in water, dissociate to produce hydrogen ion, that is H plus. So this is the definition of the acid. So one interesting thing will be there. So acid will have basicity and base will have acidity. So look now, the basicity of an acid refers to the number of the moles of hydrogen ions that can be produced by 1 mole of the acid. So whatever the number of the H plus ions that will be produced, that will be equal to the basicity of an acid. So hydrochloric acid is a monobasic because when it is dissolved in water, it produces 1 H plus ion. So that's why this is because of 1 H plus is there. So that's why this is called monobasic. Here is another example. Sulfuric acid is a dibasic acid. So when this is dissolved in water, H2SO4 is dissociated into 2H plus SO4 2 minus. So look now, you can see 2H plus are there. So that's why this is called dibasic acid. The hydrogen ion H plus is responsible for all acidic properties. So here is another very important point. The hydrogen ion H plus is responsible for all acidic properties. Next thing that we are going to read is the physical properties of acids. The first physical property is acids taste sour. This is confirmed. Whenever you taste an acid, so this is dangerous. You should not taste any acid that can harm you. But the taste of acids is sour. The second property is acid solutions have pH values which are less than 7. So this is another property that is confirmed. pH value will be lesser than 7 of acids. Next property is acid solutions turns blue litmus paper red. And the last property of acids is acid conducts an electric current. So acid conducts, actually they pass through the current. That means conducts. So acid conducts an electric current. And here is an video. Here is a video that is actually acid's litmus paper. So watch it now. When blue litmus paper is dipped into acid, so look now. So it is going to be dipped into acid. It will turn red. So look now, the portion which is dipped into the acid will turn into red. So this is the property of the acid. So it is confirmed that this liquid is acid. It turns red. So this is the property. Okay. Move on. Next, we are going to read the chemical properties of the acids. So this is the general equation of first property. When acid react with any metal, makes salt and hydrogen. So remember, learn this general equation. Whenever acid react with metal, makes salt and hydrogen. So this is confirmed. So now we will take different examples of the acid with the metal and we'll see that will make salt and hydrogen. So you have to learn this equation, general equation first. So look now, metals above copper in the electrochemical series react with dilute acids to produce a salt and hydrogen gas. So reactive metals such as sodium reacts explosively with acids. So this is another very important point to remember. Reactive metals such as sodium reacts explosively with acids. So here is our example that we are going to read, that is hydrochloric acid and acid is going to react with magnesium, that is a metal, so forms MgCl2 plus H2. So a salt and hydrogen gas are made. So here is another video, but first you have to read this equation. Whenever acid reacts with bases, the products are salt and water. So this is another general equation which you have to learn. So acid and bases react to form salt and water. Acids react with bases to form salt and water only. Acid-base reactions are also known as neutralization reactions. So this is a special name which is given to these kind of the reaction. So these kind of the reaction in which acid and base react to form salt and water, these kind of the reactions are called neutralization reaction. H plus ions from acids react with OH negative ions from the alkalis to produce water. So H plus ions from acid come and OH negative ions from base come, and when they will react, H2O, water will be produced. So here is an example now. You are going to read sulfuric acid plus sodium hydroxide. When they react, forms Na2SO4 plus H2O. So acid and base react, form salt and water. The next reaction is acid and carbonate. When they react with each other, they form salt, water and carbon dioxide. So this is the general equation which you have to remember, which you have to learn. So whenever acid react with carbonate, they form salt, water and carbon dioxide. So we are going to read our equation which will tell us how this work. So acids react with carbonate with the evolution of the carbon dioxide gas. So here is an acid, that is HNO3, and here is a carbonate, that is zinc carbonate. When they react with each other, they form zinc carbonate plus water plus carbon dioxide. So look at the general equation and here is the reaction. So one more thing for you people is practice a lot these reactions. So write these reactions as maximum as possible and practice a lot, because there will not be much time in the paper to write the equation, think about and then balance them. So you have to very strong grip on the reactions. Okay, further on, AQ. AQ stands for aqueous. So in the reactions, whenever you see AQ, that will stand for water. There is no reaction here, just dissolving. So water does not take part in the reaction. Its formula need not to be used. So aqueous stand for, this is just dissolved. There is no need to write the formula of the H2O here, and that will not take part in the reaction also. The Latin word for sour is acidus. So actually we have read a line earlier that acids have sour taste. So sour stands for acidus. Most of us like a little acid on our fish and chips. These teenagers are enjoying a little ethanoic acid on their chips. So actually the ketchup which we put on the fries or fish or nuggets, actually that is having a weak acid. That's why the taste that we feel is sour and we enjoy it. So actually that is having a weak acid that is called ethanoic acid. So this is the acid that actually we like. So look now, they are putting ketchup on their fries and nuggets and enjoying them. Citric acid gives oranges and lemons their sharp taste. So whenever you taste orange or lemon, they are having very sharp taste. Actually, these fruits are actually having citrus acid. This is another acid which is actually having sour taste but very strong one. These fruits also contain ascorbic acid. We know it better as vitamin C. So actually vitamin C is ascorbic acid. Rainwater is also slightly acidic. Carbon dioxide gas dissolves in the rain as it falls. So when the water falls from the clouds in the way to ground, they actually dissolve carbon dioxide from the atmosphere. So water is dissolved in carbon dioxide gas, and that make actually carbonic acid, which is a weak acid. So rainwater is also slightly acidic. Carbon dioxide is the gas in fizzy drinks such as cola beer and sparkling mineral water. Why do you think these drinks taste tangy? So whenever you drink Coca-Cola or Pepsi or like any drink, they are actually having fizzy feel. So actually they are having an acid into it. So actually they are having acid. So cola beer and sparkling mineral water. These are all examples of the weak acids and we meet in everyday life. Okay, on the other hand, HCl and HNO3 and H2SO4 are the strong acids. So listen, another thing regarding your papers. In the paper, you are normally required to write some examples of the weak acids. So ascorbic acid, citric acid, carbonic acid. So these are the examples of the weak acid. And sometimes you are required to write the names of some strong acids. So HNO3, HCl, H2SO4, these are the examples of these strong acids. So did you know that we all have one of these strong acids in our stomach? Hydrochloric acid actually is there in our stomach. So that is a strong acid. So you know, sometimes we feel acidity after eating some kind of particular meal. So we feel acidity over here. So look now, hydrochloric acid is used to break down our food into smaller molecules. So hydrochloric acid is there in our stomach. Acids need water before they can show their acidic properties. Without water, substances are not acidic. Okay, some acids which are obtained from plants and animals are named as organic acid. So this is another very important point. The acids which we obtain from the plants or animals are called organic acids, and organic acids are normally weak acids. So look now, here are some examples. Acids which we obtain from the plants are citric acid. These are obtained from oranges and lemon juice. Tartaric acids are obtained from grapes, and ascorbic acid is obtained from citrus fruit like blackberries. And acids which are obtained from the animals are hydrochloric acid, that is human stomach, acetic acid, muscles during vigorous exercise, uric acid in urine, excretory product from the DNA in the food, methanoic acid ant sting, and lactic acid is obtained from sour milk. Okay, moving further. Later, chemists found ways of making HCl, HNO3, H2SO4 from the minerals. They called these acids mineral acids. So here is an other very important point to remember. The acids which are obtained, which are made from minerals, are called mineral acids. We describe mineral acids as strong acids and organic acids as weak acids. So this is another very important point. The acids which are obtained from mineral acids are strong acids, and the acids which are obtained from organic from fruits or animals, these are called weak acids. These are called organic acids. Acids with low pH values are strong acids. So this is another very important point to remember. So the things which are having pH lesser than 7 are called acids. But in this category, lesser than 7, the acids which are having low pH will be more acidic, and the acids which are having high pH will be less acidic. And this is the sign which is normally put on the containers which are having acid. So this is the sign. This question normally comes in the MCQs paper. Okay, there is another very important topic in this category, that is strong and weak acids. So do not confuse these two things, strong and weak. So strong acid is an acid which dissociate all H plus into the water, and weak acid is a acid which partially dissociate its H plus into the water and keep some of them. So this is the difference. So look now, a strong acid dissociate completely in water to produce high concentration of the hydrogen ion. That is, here is an example, HCl. So HCl is having only one H plus. So look now, that is actually dissociating full H plus. So that's why this is called strong acid. A solution of the dilute hydrochloric acid does not contain HCl molecules. Contain HCl molecule. All HCl molecules have dissociated into H plus and Cl minus ions. Examples of the strong acids are HCl, H2SO4, and HNO3. On the other hand, weak acids. A weak acid dissociates partially in water to produce a low concentration of the hydrogen ions. For example, CH3COOH. So in the formula you can see there are 4 H, but it will dissociate only the last one. So look now, this is dissociated and this is keeping these 3 H plus, 3 H. So that's why this is called weak acid. A solution of the ethanoic acid contains a large number of the undissociated CH3COOH molecules and a small number of the CH3COO minus and H plus ions. Example of the weak acids are H2CO3, that is carbonic acid, and all organic acids are weak acids. When an acid is dissolved in an organic solvent, no dissociation occurs. So this is another very important point to remember. When acids are dissolved in organic solvents, no dissociation occurs, but for dissociation to occur, acid should be dissolved in water. Water is necessary. The acid is not able to show its acidic properties because no H plus ions are produced. Without the presence of the ion, the acid solution does not conduct electricity. Okay. Next is strength and concentration. So here are coming some more terms. So actually you people are now going to deal with 4 terms: strong, weak, concentrated, and dilute. So these 2 terms are easy for you because you have gone through the others. The acids which dissociate completely are called strong acid, and the acids which dissociate partially are called weak acid. So these 2 terms are easy for us now. And now here are 2 more terms, that is concentrated and dilute. So look now, concentrated. If we dissolve greater amount of the solute into a given quantity of the solvent, that will be called concentrated solvent. But if we dissolve less quantity of the solute into the solvent, that solvent will be called dilute solvent. The example is here. If we dissolve 5 spoons of salt into a glass of water, and in the other glass of water we dissolve only 2 spoons of the salt. So in first glass 5 spoons of the salt are there. In the second glass of water, 2 spoons of the salt are dissolved. So first glass will be concentrated solution, second glass will be dilute solution. So remember it. So look now, when referring to acid and bases, it is important not to confuse the terms strong and weak. and with concentrated and dilute. Concentrated and dilute refers to the amount of the acid or base dissolved in a given volume of the solution. For example, a concentrated solution of the hydrochloric acid can be formed by dissolving a large amount of hydrogen chloride in a given volume of the water. By dissolving only a small amount of hydrogen chloride, a dilute solution of the hydrochloric acid is made. So this is the difference in concentrated and dilute. Hydrochloric acid, HCl, is a strong acid since it donates protons readily and is completely ionized. So that's why this is called strong acid. A solution of the acetic acid, that is CH3COOH, may also be concentrated. So yes, this is the thing. So the solution of the CH3COOH may be concentrated because you have dissolved a lot of the CH3COOH in a given quantity of the solvent. But this is other thing. And the other thing is, this is weak acid because this will not dissociate completely. So this is the thing which you have to remember. But it is a weak acid because it does not donate protons readily and is only partially ionized. The strength of bases is defined in terms of their strength as proton acceptors. Strong bases accept protons readily, weak bases do not. Okay, further, this is very important topic which has come many times in the paper. So sour milk. So this is the question, why milk sour after some days? So the reason is here, look now. The pH of the fresh cow's milk is about 6.5, where milk spoils, we sometimes say it has gone sour because the taste of the taste it develops. From what you know now of chemistry, would you say the pH of the spoiled milk is higher, lower, or the same as that of the fresh milk? So if the pH of the fresh milk is this, and if it has gone sour, it means the pH value will come come lesser. So the pH of the sour milk will be less than 6.5. So reading further, we know that one of the characteristic of the acid is that they taste sour. We can infer then that as milk spoils, it becomes more acidic. With an increase in the acidity, the pH of the substance drops. So this is the point. Therefore, it's reasonable to assume that the pH of the spoiled milk is lower than the pH of the fresh milk. Test this for yourself. The acidity of the sour milk actually comes from the formation of the acid forms as lactic acid. So this is the reason why milk gets sour. So actually milk gets sour because of the formation of the lactic acid in the milk. The acid is produced by the bacterial fermentation of lactose. So this is responsible, this bacterial fermentation is responsible for forming lactic acid in the milk. Lactic acid is a hydroxy acid with the chemical formula. So this is the formula of the lactic acid. It is colorless or yellowish, syrupy liquid that mixes readily with water. It is widely used in the foods and beverages to bring out some flavor. So actually, whenever you go to some Chinese restaurant, the food there actually you get some kind of very particular taste. So you like that taste. Actually, that is sour taste. So they use lactic acid in some of their products. Okay, here is another very important question. So sometimes you get acidity after eating some kind of the food, particularly whenever you go to some wedding ceremony, the spicy and oily food makes some acidity in your chest. So actually you use some like some tablets. These are called Alka-Seltzer tablets. So how they work? So come now, we are going to read. Alka-Seltzer is a commonly used and acid. The ingredients of the Alka-Seltzer react with ACl in the stomach to produce carbonic acid. So this is the function of the Alka-Seltzer tablet. When we drink it with water, that makes actually H2CO3. That ACl is converted into H2CO3 because of the function of the Alka-Seltzer. So carbonic acid is a much weaker acid than ACl, and so a neutralizing effect is felt. So this is the function. So there is no need to read more. So Alka-Seltzer function is actually it converts strong acid in our stomach into carbonic acid, which is less strong or a weaker acid. That's why we feel relief after drinking Alka-Seltzer with water. So this was the topic, students. Okay, another topic is here. Safe handling of the acids. Eye protection must be worn. Carrying bottles of the acid must be done with care. Acid spills must be neutralized with safe alkali such as sodium hydrogen carbonate and washed away with water. Acid in eyes and on the skin must be washed with lots of the plain water. Immediately and medical checkup should be made to ensure no lasting damage has been caused. So this was the topic, students. Read this topic again, learn it, understand it, and make your notes. Thank you so much.